Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thank you for attending today's webinar, AuPRO 6 New Powerful Tools for Fiber Optic Users. My name is Christy Consalvo. I'm a new product manager here at Pion, and I'm excited to be part of this growing company. I'll be walking you through the tools available to you during this webinar and introduce our speaker. If you have any questions during the webcast, you can submit them to the questions section of the control panel on your screen. We'll try to answer these at the end of the webcast, but if a longer answer is needed or we run out of time, that will be answered later via email. Please note we do capture all questions. For the best viewing experience, we recommend using a wired internet connection and closing any programs or browser sessions running in the background that could cause issues. Webinars are bandwidth intensive, so closing any unnecessary browser tabs will help conserve your bandwidth. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenter. Some networks cause slides to advance more slowly than others, so logging off your VPN is recommended. You can find additional answers to some common technical issues located in the help section at the top of the control panel. Now I'm happy to introduce you to Konstantin Tsinman, our Chief Scientific Officer at Pion. Welcome, Konstantin.
Thank you, Christy. Thank you for a nice introduction. And hello, everyone. Today I'm happy to unveil a new version of Pion AuPRO software and share with you some new capabilities and features that have been added to the software. As much as I would like to introduce all new features of the software to you, I must mention that this presentation is thought to be only an introductory one to the AuPRO version 6, and it is planned to be followed by a series of other webinars that will focus on particular capabilities and applications of the software and will go to much deeper technical details. Here's a list of the topics that I plan to cover during today's presentation. It's a brief comparison with previous versions, new user interface features. I'll show you some automation in the flux calculations, and we'll talk a little bit more about flux measurements in general. I'll show implementation of multi-component regression analysis in analyzing spectral data with example study of Excedrin, the 3-API drug product. And I will also talk about extending of zero-intercept method capabilities, namely getting standard curve for nanoparticles or dynamically forming colloidal systems. So getting the standards of the spectral features which are not known a priori. A table on this slide tries to summarize some of the key features of the software. White background in the column indicates new capabilities that were not available in the previous version. It also shows which features are part of the standard package and what are included in the advanced package of the AuPRO. I don't anticipate you to read all the lines here. The slides will be available later on for all registered attendant of the webinar. And in the next slide, I tried to zoom in on the features that are new to version 6, and we'll try to illustrate some of them during this webinar. So what are these new features? 1 nanometer resolution is now available in version 6, meaning that you can select odd or even wavelength for your calculations, and the wavelength or absorbance will be exported to Excel with 1 nanometer resolution. Sample and component ID are now part of the record, so you can assign them to your samples. There is new report which will be doing report to the HTML format, and it will enable to look at the web browser. They will export in some scatter parameters which can be useful for more advanced analyzing of the nature of your precipitation. Context help is available throughout the software in this version. The Flux Calculation are available in advanced version of AuPRO 6. Doing the standard the regression analysis with up to 4 different components is available, and reconstructing of the spectra of nanoparticles is also available in AuPRO 6. Let's begin with the interface. For those of you who are familiar with the software, there will be some changes to the quick access toolbar buttons. For example, a somewhat confusing toggle between diagnostic and experimental mode is eliminated, and the diagnostic mode can be invoked now with its own button. We have also tried to place buttons in the logical sequence how operations are supposed to follow in the majority of cases, namely normalize the instrument, scan in the diagnostic mode to ensure that there's no air bubbles or contaminations, collect standards, and run the experiment. You will also see new buttons that are associated either with some new or modified capabilities of the software. Namely, it's report into the HTML format, view all spectra toggle. So now from the toolbar, you can either switch all spectra on and off, and depending on the standard or sample tab, it will work there. The help is now having access to the entire instruction manual, and there is a context help button. Task editor gets expanded to allow sample and assay relevant information to be entered before assay, as shown in this recording. For example, a user can enter the sample ID and then press a little button to populate it to all channels. And the same can be done with component ID, which in general case can be different from the sample ID. So as well, potency can be entered either individually per channel or for all channels. Media can be selected from a list of predefined media or entered as an entry, user entry, and volume can be changed to either small volume or large volume dissolution. The time intervals are displayed now in a simulated dissolution curve that minimizes the chance for erroneous entries. So you can actually see ahead of time the data density which you are trying to collect. Another introduction to the software is the context help. As illustrated in this recording, the 100% T, dark, or standard chapter of the instruction manual are open depending on the corresponding software tab that is active in the background. Most dialog boxes have help button that will open corresponding page of the instruction manual as well. Presenting data in the tabled format is another new feature of the software. You can see the absorbance and concentration data in the tabled format for all data points in the real time or after the experiment. From this view, a report can be formed by entering certain parameters of your experiment and then pressing report button. And this report is export to the browser-friendly format and can be opened in any browser, either on a computer or on a handheld device. The points can be excluded directly from the standard curve. That's another new feature, without need of switching back and forth between standard curve and standard spectra U. Similar to the previous version, exclude spectrum function will disable a particular concentration in the selected channel, while set not active will disable selected point in all channels. Status of the assay is accessible at any time during the run by clicking the corresponding status bar area. And let me show it in this recording. It shows elapsed and remaining time, number of points collected and left before the assay finish. There are other changes. Okay, so there are other changes in the interface that were introduced based on numerous suggestions from users of the software, and we are grateful for all your feedback. However, I'd like to focus on the features that added new functionalities to the AuPRO software. Due to the complex interplay between solubility and permeability, the flux of the API through membranes mimicking biological barriers has been identified as a critical factor governing the formulation development. Pion provides several products that enable flux measurements in parallel with biorelevant dissolution studies. Here you can see a picture of microflux that can be used with the small volumes in the early development stage. You can see macroflux, which can be used with a final products on USP dissolution apparatus. And our recent addition is bioflux, which also works on the USP apparatus, but can work with biorelevant volumes around 250 milliliters. Several recent publications are listed here for your reference if you'd like to read more about flux measurements and what kind of predictions or informations can be taken from these measurements. What is flux? It is the rate at which compound penetrates through membrane to the receiver compartment. The rate is normalized by area available for the transfer, so the flux becomes irrelevant to what kind of area is available. How flux value were calculated in previous version of AuPRO, because some of you may already run in flux measurement. So a user would usually follow these 4 steps to calculate flux. The export concentration time profile in the receiver chamber to the Excel. In Excel, they find the interval, time interval to fit the profile with a straight line. Display the equation for the fit line and record the slope of this line. And finally, they will normalize, but by multiplying the slope value with volume in the receiver and divide by the membrane area to obtain the flux value. Well, even exporting concentration to the Excel, although trivial, was not very convenient for the flux measurements. AuPRO software used to always export all data to the Excel regardless of the view settings. An example is shown on this slide. If concentration time profile is linear, namely flux is constant, then it was not an issue. After exporting data to Excel, any time interval after the lag time could be selected for the linear fitting and flux calculation. However, if flux was changing due to supersaturation precipitation phenomenon happening in the donor, it could be very inconvenient to seek for the linear intervals through the entire data table in the Excel. With new software, user can export to Excel only a portion of the data that are relevant to the task in hand. It can be accomplished by using available zoom in out tool of the software. So first, to select required linear interval that can be individual for each channel. So right here, it's selected particular interval for all even channels which represent the receiver chambers in this case. And then exporting context data to Excel. So only portion of the data is exported. It can be easily fed by a straight line to calculate flux. This particular feature is not specific to the flux experiments and is also useful in media conversion assays when the first gastric medium portion and follow-up intestinal a portion of the assay may need to be exported in separate files. Then specifically for the flux assay, the software allows user to specify the assay type in the general information dialog box, as can be seen here. So assay type, you can select flux. The area field becomes available when either flux or disk IDR assay type is selected, and the area specific to a particular flux setup must be entered here. This slide shows receiver chamber in the microflux assay where different formulations of the same compound were applied in donor, and they produce different responses in the receiver chambers. When the assay type is specified, this expands the capability of calculate options. And again, this is another topic for future webinars. And this option would enable flux calculation. So this I'm just showing the option calculate within the software. Namely, the algorithm tries to fit the concentration time profile with linear or exponential fit depending on what fits better, and then reports the flux value that depend on the slope of the curve. Evidently, in this example, except for channel 1 and maybe 2, the fit doesn't work well for entire. So this just shows the flux calculation. That's why the software allows establishing the calculation limits in each channel from a context drop-down menu button. Thus, the custom-defined flux calculations are available. The vertical bars limiting the field symbol show time range selected for the curve fitting. The result can be exported to the Excel file using export functionality. And this is usual context export functionality. The flux value and time range will appear in the table on the concentration time profile tab of the Excel. Most other parameters exported are not related to the flux measurement. They are related to characterizing powder dissolution experiments. This will be one of the future webinar topics. In the next group of slides, I'll focus on the new capability of AuPRO 6 software that makes it even more powerful. For those of you who are familiar with zero-intercept method, or ZIM, it may already may already use the capability of the software to monitor simultaneously 2 active ingredients without any need for chromatographic separation. What about cases when more than 2 API are combined in the drug product, or when non-active ingredient absorb light? AuPRO version 6 enables user to apply multi-component linear regression analysis to resolve up to 4 UV absorbent components in the mixture. How does this method work? Let's consider that we have a set of absorbent components where we can measure the standard spectrum at known concentration for each of these compounds. In order not to be very abstract, consider a combination product consisting of 3 APIs, so we can collect 3 standards at known concentration: standard 1, standard 2, and standard 3. Now, let's assume that there is no chemical interaction between components that would change their molar absorptivity. Then a sample spectrum will represent a superposition of all absorbing components, or in our example, component 1, component 2, and component 3, where coefficients X determine what portion of each standard spectrum is present in their superposition or in the sample. AuPRO 6 implements the least squares method to the regression analysis to determine the coefficients X and thus concentration of each component in their mixture. It's important to note that regression can be done on the second derivative as well, meaning that regression can be done in the turbid solution, applying all turbidity correction, which is beneficial in the second derivative spectroscopy. The multi-component regression implemented in AuPRO 6 was tried, among others, on the over-the-counter medicine Excedrin. The spectra that I showed in my previous slides actually belong to acetaminophen, aspirin, and caffeine, all parts of Excedrin product. This slide demonstrates on a real example how the sample and components names, as well as potency and other assay parameters, can be entered at the start of the experiment. So here the sample ID would be Excedrin, and the components ID would be acetaminophen, aspirin, and caffeine, and all of them have different, or may have different potency. Acetamin has 250 milligram, the same for aspirin, but caffeine only has 65 milligram potency in each tablet. Here we quickly review again the spectra of all components: acetaminophen, aspirin, and caffeine. So now we name them. And the second derivative of all 3 components. AuPRO 6 adds a special view that empowers method development for multi-component regression analysis. Usually such method development consists of adding known concentration of various components and selecting the analytical, regression range that ensures component resolution. Other common parameters selected during method development assay is steep path length. In our case, we had to switch from 2 millimeter path length steep to 1 millimeter due to signal saturation when all components were present in solution. After method was developed that could be done at the same time of standard collection, by the way, the dissolution experiment was conducted in 4 vessels of USP to dissolution bath with measured values to be within 5% of labeled potency. This topic covers added versatility of AuPRO software to deal with nanoparticles, whether they are of crystalline nature or forming dynamically when concentration of dissolved drug exceeds its amorphous solubility limit and liquid-liquid or glass-liquid phase separation occurs. So what are the issues with nanoparticles and why it requires the special treatment? First of all, consider challenges that are facing in situ measurements when dealing with nanoparticles. Nanoparticles scatter light with non-linear background, but they also absorb light, changing the spectral characteristics. Amorphous formulations can form colloidal nanoparticles when precipitating or when undergoing liquid-liquid phase separation. That also changes spectra. So what it means on practice that we don't know the spectral characteristics of nanoparticles ahead of time. How can additional light absorption from particles be recognized? And can spectrum of nanoparticles be separated from its superposition to form a standard for the analysis? So these kind of questions we try to answer during development of AuPRO 6. Can a nanoparticle standard spectrum be used in multi-component regression analysis to monitor concentration of nanoparticles and free drugs simultaneously? So now we would try to combine the features of multi-regression, multi-component regression, and separation of nanoparticles spectrum. How can analysts recognize? So let's just step back a little bit and ask the question, how can analysts recognize the appearance of additional absorbent component? On the left plot, we see the second derivative. Let me just grab the pointer. We see the second derivative spectrum of compound naproxen, which is fully dissolved in the solution. So it was introduced in the solution as nanoparticles, but because the load of it was below its crystalline solubility, everything was dissolved. On the right plot, the load of nanoparticles was 30 microgram per milliliter, which is above its crystalline solubility. Are these spectra the same? It's sometimes difficult to answer this question from just looking at the spectrum. But it becomes very obvious if we overposition left and right spectrum on the same plot. They are different. Now, the easiest way of determining at which concentration the spectrum begins changing is to use zero-intercept method, or ZIM. Some of you are familiar with ZIM. Briefly, we're adding aliquots of the concentrated suspension of nanoparticles to the assay medium and monitor absolute absorbance values at the zero-intercept point of the second derivative spectrum of compound. When compound is dissolved, excuse me, when compound is dissolved, the signal will stay at zero by definition of zero-intercept points. So, because at these points, compound has no signal in the derivative spectrum. So, if everything is dissolved, the signal is zero. When another light absorbing phase is present in the solution, the compound becomes, the signal becomes deviating from the zero. And with adding more and more compound, we have more and more this additional signal. When we extrapolate the diagonal line to the concentration axis, we will see at what concentration now nanoparticles and dissolved compound are in equilibrium with each other. In other words, we determine the solubility of nanoparticles. Well, now, how this experiment will look in the AuPRO software for the example of nanosuspension of naproxen. Fully dissolved naproxen at concentration 12 microgram per milliliter was collected as standard in standard 2 tab. So it's not shown now. And then in standard 1 tab, over here, we were adding the aliquots of this nanosuspension. Because of the axis in the AuPRO software are reversed, so we have concentration on y-axis and absorbance on x-axis. You can see that there is a vertical portion of the curve. So that's where the signal wasn't developing in the second derivative, so everything was dissolved. And then there was a diagonal portion of the curve, so it means that now nanoparticles started absorbing. So when we look at the standard curve in the standard 1 tab, where nanosuspension was titrated, we can clearly see when a signal of second derivative begin to deviate from this vertical line. So if we exclude these points, which is, as I mentioned, is possible directly from the standard curve, we can see by the intercept what solubility of nanoparticles and difference between channels gave an idea of reproducibility of the method. So as you can see, almost for all channels, we have about the same value of 19 microgram per milliliter, which is solubility of nanoparticles of naproxen. AuPRO version 6 enables going to the next step, namely to separate spectrum of the nanoparticles from the spectrum of API. Here, how it's done. So first, we take spectrum of the highest concentration before nanoparticles form. And this is, in this case, was 12 microgram per milliliter, and intercept is 19.1 microgram per milliliter. Then we take this spectrum and we scale it up to 19.1 microgram per milliliter, which is solubility of nanoparticles. Then we subtract this spectrum, scaled spectrum, from all standard spectra above nanoparticle solubility. So at all these points, we will subtract this spectrum from the corresponding spectrum at these points. And then we save all above spectra with concentration equal to enter concentration minus this offset, which in this example was 19.1 microgram per milliliter. So for example, if the load was 30 microgram per milliliter, then this will be a standard of nanoparticles and 10.9 microgram per milliliter, which is 30 minus 19.1. So again, showing this, red is reconstructed spectrum of nanoparticles. That is blue spectrum, which was measured, scaled up to solubility, which is orange spectrum. And then this spectrum was subtracted from the measured nanoparticle spectrum, which is gray spectrum. That's how we get the red spectrum. All these operations are done automatically behind AuPRO 6 software to save standards of nanoparticles. Now, when we have standards of nanoparticles and we have a spectrum of API, so we can actually look at both of them present in the solution at the same time, and we can say that in 100 microgram per milliliter of nanoparticles load, we can see that only 19 microgram per milliliter is present in form of the free drug, and 81 is present in form of nanoparticles. There are some other features of the software which that I'd like to mention and that were left outside of the presentation, and they are listed below, and I'm not sure I actually can list all of them. So as I mentioned in the beginning, the file data structure was changed to enable data visualization with 1 or 2 nanometer wavelengths, resolution for calculation and data export, and it doesn't actually expand the size of the data file. So it doesn't matter at which wavelength resolution you work. The ability to select a wavelength range for baseline correction algorithms other than a simple point was added. So now if you select a linear baseline correction, or if there's new option average, when you can average several wavelengths for your baseline correction, or you have scatter modeling, so you can select a particular wavelength range to do this kind of correction. The baseline is now visualized in the view before it's applied to correct the spectra. So you can actually see how your baseline looks like and whether it will overcorrect the spectra. There is an advanced spectral smoothing capability added to the software, which can work in some special cases. And so we still learning in which cases it will give the benefits to the users. And in the case of the scatter modeling of the baseline, the fitting parameters are exported to Excel and can be used for the nanoparticles sizing estimation. This is kind of an interesting feature which we explored a little bit, and we have a poster presented on this. So if you're interested in learning more about this, please contact us, and we can share with you the poster which was presented at APS meeting last year. I'd like to mention the last but not the least, the software is available now. Please contact us by sending your inquiries to sales@pioninc.com, or if you have technical questions regarding the software, you can send them to techsupport@pioninc.com. At this moment, I would be happy to take your questions, and I'll try to answer them during this Q&A session, or if they are kind of require more time for answering, we'll answer them over the email, as Christy mentioned in the beginning of the webinar.
Thank you, Konstantin. So as a reminder to enter your questions, enter them into the questions section of the control panel on your screen. And we'll give people a few minutes to go ahead and enter their questions. Actually, our first question is, will the software work with older instruments?
There are some legacy instruments which we sometimes call short range, where we're allowed data collection only up to 390 nanometers. And they sometimes technically call R2B or R2C type. The software is not compatible with these instruments, and you may already know that Pion is discontinuing support for this instrument. So if you have these instruments, please contact our commercial team, and they will work with you on your options.
Okay, thank you, Konstantin. The next question is, could you talk a little bit more about the averaging with the baseline?
Yes, sure. So in this version of software, there are 4 types of the baseline correction. And you may be familiar with point correction when a single waveline is selected, line correction when we fit a certain portion of the spectrum with a straight line and then subtract this line from entire spectrum, and the scatter modeling, which is a more complex correction. The average baseline correction, it's similar to the point correction, but instead of taking a single wavelength, we measure wave absorbance at the range and then average them, and this average value is subtracted from the spectrum.
Great, thank you. Next question is, can the advanced model be activated for a period of time to try it out?
Yes, it can. So if you are not sure whether you would benefit from advanced feature of the software, the temporary activation is available.
Right, thank you. So the next question, is there going to be other webinars, and is there a schedule of those webinars?
Yes, we are planning to give a series of webinars focusing on, they may be shorter in time, and they will focus on a particular feature of application of AuPRO 6 software, and we're working on the schedule, so please visit our website and check out the schedule of events. We will post it there.
All right, thank you. Thanks, Konstantin. And actually, one more question here. When using FASSIF or FESSIF media containing micelles and vessel cells, which might change in composition, size, or shape upon interaction with the API, how does this influence spectra analysis, especially ZIM? Do they have similar nanoparticles and changing absorption?
That's a very good question, and this is something which can be studied ahead of time. So in my example, I showed crystalline nanoparticles of naproxen, but we did similar experiments when we introduced compound pre-dissolved in solvent, and then after a certain concentration, the spectra were changing, and we were using it in the simple buffer and also in the passive medium. So in these spectral changes can be registered, and the new spectrum can be separated using the similar technique as I showed during my presentation.
Great, thank you. The next question, have you used the microflux to study drug release from nanoparticles? Where the nanoparticles are carriers for a drug, for example, liposomes?
We did use micro dis and microflux. I'm sorry, was it microflux?
Microflux, yep.
Yeah. We did use microflux for nanoparticles, which are vehicles for the API. Again, it needs to be validated for a particular type of nanoparticles, but we did use them. So in terms of liposomes, there are different approaches to liposomes. We can use different type of membranes, which would be, some of them as just size exclusion membranes, which would be restrictive for liposomes, but API can diffuse through these membranes.
Great, thank you. And thank you all for attending today's webinar. If we didn't get your question or you have one after the webinar, you can always email sales@pion-inc.com. That's on the screen right now. You'll receive an email after this webinar with a link to a survey, which we kindly ask that you complete to help us improve future webinars. Thanks again, and we hope that you have a wonderful day.